what is a normal extension? This is the first question that comes to our mind. An extension field. We have been so far studying about extension fields. Suppose this F is the given field that is given to us and B its extension field. Then we say this extension field would be a normal extension field of F if it satisfies any one of the following statements. So the first statement here is, it is also given that this field E, this is an algebraic extension of F. This is given to us such that it is contained in F bar. And what is this F bar? F bar is the algebraic closure of F. So this is given to us. So if every irreducible polynomial in f of x having a root in E splits into linear factor in E, then we say this given extension is normal over F. Now notice that we use the word every here, right? And in the second point says that if E becomes the splitting field of the family of polynomials in fx. So here you have many polynomials. Say f of x is one polynomial, f1x, f2x is another polynomial, fnx is another polynomial, fix is another polynomial for general I. So all these polynomials are present in f of x, and we say this field E forms the splitting field for all these polynomials. That means all these polynomials, they will surely have roots in E, and moreover these polynomials could be written as the product of linear factors in E. If this thing happens, we say our extension, that is the normal extension. Next, third point says every embedding. What is embedding? Sigma from E to F. So this is a mapping which is 1-1 and homomorphism. If a mapping is 1-1 homomorphism, we say,
मैम स्क्रीन पे कुछ नहीं दिख रहा है.
So it says every embedding. What is embedding? Embedding is a mapping that is 1-1 and homomorphism. So now this mapping which maps every element of E to every element of F bar, and it keeps elements of F as fixed. This maps E onto E. If this condition is true, then we say the given extension field is also a normal extension. So all the above statements, they are equivalent. We will prove this in very recently, that all these three statements are equivalent. So it means that if any of these three things is satisfied by any extension field, then we say the given extension field is the normal extension field. Another definition which is parallel to this one, it says that an algebraic extension E of a field F is called normal. Whenever you have an algebraic extension E of F and every irreducible polynomial in f of x, so you have F here, you have E here, and you take any irreducible polynomial here. So this polynomial, say we take Px. So this polynomial should split into linear factors in E. So this is what they are saying, and it should be true for every such polynomial. If that is the case, we say our given extension field, that is the normal extension. So now you might be thinking that this is very similar to that of definition for splitting field. We have done the same thing for splitting field, but the difference here is that in splitting field we were only talking. आवाज ही नहीं आ रही. So here this definition is very similar to that of splitting field, because in splitting field also we took one polynomial in this lower field and we were talking about the splitting of this field into linear factors in this upper field E. But now here the difference between splitting field and normal field, it lies in the fact that in normal field we say there are plenty of polynomials here. Say P1, P2x, Pnx, Pix, there are so many polynomials here in F. All of these polynomials, they should split into linear factors in E. So this is what we are saying. So instead of one polynomial which we took in splitting fields, we now talk about the family of irreducible polynomials. So what is this family of irreducible polynomials? So usually what is the meaning of a family? Family is one which have different individuals and a single link. The single link, that is the parents, right? So family of irreducible polynomial is also having different polynomials which are all irreducible in nature. So the single link over here is that of irreducibility. And how do we mathematically express any family of polynomials? Suppose fix, this is the family of polynomials. How this is a family of polynomials? Here I belongs to this indexing set, so that is known as the family of polynomials. Why family? Because in this indexing set we have many numbers. So according to this many numbers, you have different polynomials in this family. So the splitting field of any family of polynomials, it consists of an extension field such that each polynomial splits into linear factors, first thing, and moreover the extension field which is generated over f by all the roots of this family of polynomials, it should be generated by f, and it should contain all the roots of polynomials fix present in this family. So this is the definition and this is the meaning of family of irreducible polynomial in this, right? So next we have, so let us see an example of normal extension of the given extension. We all know that the field of complex number, that is the field extension of this real numbers. So now this is also the normal extension. This is also the normal extension of the given field. Why? Because every polynomial in R, whichever polynomial you take, say x square plus 5, this is the given polynomial. So it has roots in C. What are the roots? One is square root 5 iota, another is minus square root 5 iota. So these are the two roots for this particular polynomial. And if you take any polynomial in R, because by fundamental theorem of algebra, we know that C has its root in it. The roots of that particular polynomial would be present in C. So we say every polynomial in R splits into linear factors in C. Thus C acts as normal extension of the field of real numbers. But the field of real numbers, that is not normal over Q. Why this is so? So we are saying, we know this Q is the field extension. Q is the subfield of the field of real numbers, or R is the field of extension field of this field of rational numbers. So if R is normal extension, then all the polynomials in Q, they should split into linear factors in R. This is required for the definition of normal extension. However, we find one polynomial, say x cube minus 2, in this lower field Q of x, such that its root, one of its root is x is equal to 2 to the power 1 by 3, but the other two roots, they are complex in nature. So they do not belong to R. But according to definition, it should have all the roots and the polynomial should split into linear factors, but this is not happening for this particular polynomial. Hence we say that this is not the normal extension. R is not the normal extension over the field of rationals. Next example is that of Q alpha. So we are saying this Q alpha, where this Q is the field of rational numbers that is adjoined with alpha. So this is the normal extension. This is the normal extension for this field of rational numbers, where what is this alpha? Alpha is e to the power iota pi by 4. So because we know what is e to the power iota theta, this is equal to cos theta plus iota sine theta. Therefore e to the power iota pi by 4, this is equivalent to cos of pi by 4 plus iota sine of pi by 4. So this is our alpha. Now because this is the root of this polynomial. What is this polynomial? X raised to power 4 plus 1 is equal to 0. This is the polynomial equation. So now we can calculate what is x from here. It would be minus 1 raised to power 1 by 4. So we would be interested to calculate its root, the root of this particular polynomial here. So that could be found by one of its root is this one, which is the root of unity, right? The fourth root of unity. So when you take its power, so other root would be e to the power 2 iota pi by 4. Next root would be 3 iota pi by 4. Next root would be e to the power 4 iota pi by 4, and so on. So these are the four roots that are available in this Q alpha. Why these are available in Q alpha? Because the basis set of Q alpha is 1 alpha, alpha square and alpha cube. So we can say that this Q alpha, this forms this normal extension over this field of rational numbers for this particular polynomial x raised to power 4 plus 1. In fact, if you take any polynomial here, you can split that into linear factors in this polynomial. So I think you got the concept of this normal extension.